Welcome back to the deep dive. Today, we're going to try to tackle something that feels, well, incredibly relevant to pretty much everything. Decision making.
Right.
You know those moments where you're faced with choices and you're trying to figure out the absolute best path forward?
Right.
We've got this study guide that promises to give us a framework for making smarter decisions,
Oh, wow.
even when things get super complex.
Yeah, what's fascinating here is that it goes beyond just gut feelings or intuition.
Right.
It dives into the science of decision making using a field called operations research, or R for short.
Okay, I'll admit that sounds a little intimidating at first glance.
Yeah.
Is this going to be all equations and algorithms?
Well, not necessarily. While OR does use mathematical tools, it's really about applying a structured and logical approach to problem solving. Think of it as a way to break down complex situations into manageable pieces
Okay.
and then use data and analysis to find the best solutions.
Okay, that makes sense.
Uh-huh.
So where do we even begin with something like this?
Well, the study guide starts by introducing the fundamentals of OR. It explains how this field evolved from its roots in wartime planning
Oh, interesting.
to addressing a wide range of problems in business, government, and even everyday life.
Wartime planning. So like figuring out the best way to deploy troops or allocate resources.
Exactly. During World War II, mathematicians and scientists were brought together to solve logistical challenges and make the most of limited resources. And those efforts really laid the foundation for modern OR.
It's amazing to think that something so practical came out of such a difficult time. So how does OR actually work in practice?
At its core, OR is about building models.
Okay.
A model is a simplified representation of a real-world situation that helps us understand the key factors at play and predict potential outcomes.
So it's like a map that helps you navigate a complex terrain.
That's a great analogy. Just like a map helps you understand the layout of a city, a model in OR helps you see the relationships between different variables and how they might affect your decision. But it's important to remember that models are simplifications.
Right.
They don't capture every single detail of reality.
So you need to be aware of a model's limitations before making any big decisions.
Absolutely. That's why the study guide emphasizes the importance of validating your models with real-world data. It's all about finding a balance between simplification and accuracy.
Okay, that makes sense. Now, I'm curious about the kind of person who thrives in the world of OR. What skills do you need to be successful in this field?
Well, a solid foundation in mathematics and statistics is certainly helpful, as is a knack for logical thinking and problem solving. But OR also draws on other disciplines like computer science, economics, and even psychology.
Psychology?
Yeah.
Really? What does psychology have to do with crunching numbers and optimizing systems?
You'd be surprised. After all, OR is ultimately about human decision-making. Understanding how people perceive risk, respond to incentives, and make choices in groups is essential for building effective models and solutions.
So it's not just about being a math whiz. You need to be able to understand people, too.
Exactly. The best OR practitioners are those who can blend quantitative skills with a keen sense of human behavior and organizational dynamics.
That sounds like a pretty unique combination.
Okay.
Okay, so let's say you've got your team of OR experts assembled.
Okay.
What's the next step in tackling a problem?
The study guide outlines a systematic approach to OR problem solving.
Okay.
It starts with defining the problem clearly, identifying the objectives you're trying to achieve, and gathering all the relevant data.
So it's like a detective gathering clues before solving a case. You need to get all the facts straight before jumping to conclusions.
Precisely. It's tempting to rush into finding solutions, but taking the time to define the problem properly can save you a lot of headaches down the road. Once you have a clear understanding of the problem and your goals,
Yeah.
the next step is to build a model that represents the situation accurately.
So building the model is like creating a blueprint for your solution.
That's a great way to think about it. The model allows you to test different scenarios, evaluate potential outcomes, and identify the best course of action. Of course, no model is perfect, so it's crucial to test your solution in the real world and make adjustments as needed.
That makes sense. So OR is an iterative process. You're constantly refining your model and solution based on new information and feedback.
Exactly. It's all about being adaptable and finding the best solution within the constraints of the real world.
This is starting to paint a much clearer picture of what OR is all about. But I'm still curious about the specific tools and techniques that OR practitioners use. Can you give us a glimpse into their toolbox?
Absolutely. The study guide introduces a whole range of OR techniques, each designed to tackle different types of problems. One of the most fundamental techniques is mathematical programming, which involves using mathematical formulas to optimize a particular objective, often subject to certain limitations or constraints.
Constraints, like having a limited budget or a tight deadline.
Exactly. Mathematical programming helps you find the best solution within those boundaries. It's like figuring out how to make the most of what you have.
So it's like optimizing your choices even when you can't have everything you want.
Precisely. Within mathematical programming, there are different types of models,
Right.
each suited for a particular type of problem. For instance, linear programming is often used to allocate resources efficiently, while transportation problems focus on finding the optimal routes for moving goods or people.
It sounds like there's a whole family of techniques within mathematical programming alone.
That's right. And it's just one branch of the OR tree. There are many other fascinating techniques to explore, each offering its unique approach to problem solving.
This is incredibly insightful. I'm already starting to see the potential applications of OR in so many different areas of life.
That's the beauty of it. OR provides a versatile framework for decision-making, whether you're managing a complex supply chain, planning a city's transportation system, or even just figuring out the best way to organize your day.
This has given me a whole new appreciation for the power of structured decision-making.
And we're just getting started. There's a lot more to uncover as we delve deeper into the world of OR.
Well, I'm definitely ready to dive in. Let's take a closer look at some of these fascinating OR techniques and see what else we can learn.
Sounds like a plan.
Yeah.
Let's continue our deep dive and explore the tools that can help us make smarter choices in an increasingly complex world.
Okay, I'm ready to delve deeper into these OR techniques. Where do we go from here?
Well, remember how we talked about mathematical programming and its various applications?
Yes. It was fascinating to see how it can be used to optimize everything from resource allocation to transportation routes.
Right. The study guide dives even deeper into some specialized areas of mathematical programming
Okay.
that address specific types of problems. For instance, there's a whole section dedicated to network models, which are particularly useful for analyzing systems like transportation networks, communication networks,
Right.
or supply chains.
I can see how those would be incredibly relevant in today's interconnected world.
So how do network models actually work?
They essentially represent these complex systems as a series of interconnected nodes and arcs.
Okay.
The nodes can represent things like cities, warehouses, or even people,
Mm-hmm.
while the arcs represent the connections between them, like roads, pipelines, or communication links.
This is like creating a visual map of how things flow through the system.
Exactly, and by applying mathematical algorithms to these network models, we can optimize various aspects of the system. For example, we can find the shortest paths between 2 points,
Right.
determine the most efficient way to transport goods, or even identify potential bottlenecks that might disrupt the flow.
That sounds incredibly powerful. It's like having a bird's eye view of the entire system and being able to identify the best ways to make it work more smoothly.
Precisely. And network models are just one example of the specialized tools within mathematical programming.
Okay.
There are other techniques like inventory control.
Which focuses on optimizing the management of stock levels, and queuing theory,
Oh, yeah.
which analyzes waiting lines and helps minimize customer wait times.
Queuing theory. Now, that's something I can definitely relate to. I'm sure we've all experienced the frustration of standing in a long line, whether it's at the grocery store, the bank, or even a theme park.
Absolutely. And queuing theory provides a way to analyze those situations and find ways to make them more efficient. It helps us understand factors like arrival rates, service times, and number of servers,
Right.
and how they impact the overall waiting experience.
So you could use queuing theory to figure out the optimal number of checkout lanes at a supermarket, or the best way to design a self-checkout system.
Exactly. By applying queuing theory, we can minimize customer wait times, reduce congestion, and ultimately improve the overall customer experience.
It's amazing how these OR techniques can be applied to such a wide range of everyday situations. But the study guide also delves into some more advanced and complex areas, right?
That's right. One of the most fascinating areas is game theory.
Which helps us understand strategic decision-making in situations involving multiple players, where each player's choices can impact the outcome for everyone else.
So it's like figuring out the best strategy in a game of poker or chess.
That's a great analogy. But game theory goes far beyond just games. It's used in economics, politics, business negotiations, and even evolutionary biology to analyze strategic interactions and predict how different players might behave.
That sounds incredibly complex. How do you even begin to analyze those kinds of situations?
Well, the study guide breaks down the key elements of a game. the players,
Right.
the strategies they can choose from, and the payoffs or outcomes associated with each combination of strategies.
So it's like creating a map of all the possible moves and their consequences.
Exactly. And by analyzing those possibilities,
Okay.
we can identify the best course of action for each player, taking into account the likely actions of the other players.
This is starting to sound a bit like mind reading.
Not quite. But game theory does help us anticipate how others might react to our choices.
Right. And make decisions that are more likely to lead to favorable outcomes.
I can see how that would be incredibly valuable in a world where so many of our decisions are intertwined with the choices of others.
Precisely. And the study guide highlights some classic examples of game theory in action, like the prisoner's dilemma, which illustrates how individual self-interest can sometimes lead to suboptimal outcomes for everyone involved.
The prisoner's dilemma. I've heard that term before, but I'm not sure I fully understand it. Can you explain it a bit further?
Certainly, the prisoner's dilemma is a hypothetical scenario where two suspects are arrested and held in separate cells. They're each given the option to confess to the crime or remain silent. If both suspects stay silent, they both receive a light sentence. But if one confesses while the other stays silent, the confessor goes free while the silent one receives a heavy sentence. And if both confess, they both receive a moderate sentence.
So the best outcome for both of them is to stay silent and cooperate, right?
Logically, yes. But from each suspect's individual perspective, confessing seems like the safer option regardless of what the other suspect does. If the other suspect stays silent, confessing means going free instead of getting a light sentence.
Right.
And if the other suspect confesses, confessing means getting a moderate sentence instead of a heavy one.
So even though cooperation would lead to the best overall outcome, the rational choice for each individual is to betray the other.
Exactly. The prisoner's dilemma highlights the tension between individual rationality and collective well-being, showing how strategic decision-making can sometimes lead to counterintuitive outcomes.
That's a fascinating insight. And it makes me wonder how we can apply this knowledge to real-world situations where cooperation is essential.
That's a great question. And the study guide explores various ways to encourage cooperation in strategic interactions, such as establishing trust,
Okay.
building reputations, and designing mechanisms that incentivize collaborative behavior.
So it's not just about understanding the dynamics of competition, but also about finding ways to foster cooperation and achieve mutually beneficial outcomes.
Precisely. And that's one of the key takeaways from the study guide's exploration of game theory.
This is also intriguing. It's like peeling back the layers of human decision-making and seeing the intricate web of factors that influence our choices.
And we're just getting started. There's another fascinating area of OR that we haven't even touched upon yet. Metaheuristics.
Metaheuristics. That sounds a bit like something out of a science fiction novel. What are they all about?
Well, metaheuristics are essentially sophisticated search algorithms
Okay.
that help us find good solutions to complex problems where traditional optimization methods might struggle.
So they're like superpowered problem-solving tools.
You could say that. They're particularly useful for tackling problems with a vast number of possible solutions, where trying every single option would be computationally impractical.
Right.
Think of things like optimizing delivery routes,
Okay.
scheduling tasks, or designing complex engineering systems.
Those sound like incredibly challenging problems.
Yep.
How do metaheuristics even begin to approach them?
They employ a variety of clever strategies to explore the solution space efficiently, often drawing inspiration from natural processes like biological evolution or the annealing of metals.
Annealing of metals. What does that have to do with solving complex problems?
It's actually a fascinating analogy. Annealing involves heating a metal to a high temperature and then slowly cooling it down. This process helps to remove defects and make the metal stronger.
Okay. I'm starting to see the connection here.
In a similar way, metaheuristic algorithms like simulated annealing start with a random solution and then make small changes to it. If a change leads to a better solution, it's accepted. But even if a change leads to a worse solution, it might still be accepted with a certain probability.
Wait, why would you accept a worse solution? That seems counterintuitive.
That's the clever part. By sometimes accepting worse solutions, the algorithm avoids getting stuck in a local optimum, a solution that might seem good but isn't actually the best possible solution overall. It's like shaking things up a bit to explore a wider range of possibilities.
So it's like taking a step back to potentially leap forward later.
Exactly. And as the algorithm progresses, the probability of accepting worse solutions gradually decreases, just like the slow cooling process in annealing. This helps the algorithm converge towards a high-quality solution.
That's a really neat way to explore a complex solution space. Are there other metaheuristic techniques besides simulated annealing?
Absolutely. Another popular technique is taboo search, which maintains a list of forbidden moves or solutions that have been recently visited. This helps the algorithm avoid revisiting the same areas repeatedly and encourages exploration of new possibilities.
So it's like having a memory of past failures to guide future explorations.
Precisely. And there are many other metaheuristic techniques, each with its own unique approach to exploring the solution space. Some draw inspiration from biological evolution using mechanisms like mutation and crossover to generate new solutions. Others mimic the behavior of swarms of insects or flocks of birds using collective intelligence to find optimal solutions.
This is blowing my mind. It seems like metaheuristics offer a whole new way of thinking about problem solving, drawing inspiration from nature, and using sophisticated algorithms to navigate the complexities of the modern world.
That's a great way to put it. Metaheuristics represent a powerful and versatile set of tools in the OR toolbox, and they're becoming increasingly important as we grapple with ever more complex challenges.
This has been an incredible journey so far. We've gone from the foundations of OR to the intricacies of mathematical programming, game theory, and now metaheuristics.
It's quite a journey.
It's amazing to see how these tools can be applied to so many different areas of life.
Absolutely.
I have to say I'm feeling a lot more equipped to approach those tricky decision-making moments now. It's like having a new set of lenses through which to view the world and its challenges.
It is. And we're not done yet. There's one more fascinating area of OR that we need to explore.
Okay, I'm all ears. What else does this incredible field have to offer? All right, you said there's one more area of operations research we need to explore.
Yes. So far, we've talked about optimizing systems and strategizing in competitive situations. But what about when cooperation is key?
That's a good point.
That's where cooperative game theory comes in.
Cooperative game theory. So it's like regular game theory, but with a focus on collaboration instead of competition.
Exactly. While traditional game theory often assumes players are acting in their own self-interest,
Right.
cooperative game theory explores how individuals or groups can work together to achieve a common goal.
That sounds incredibly relevant to so many real-world situations. Think about business partnerships, international treaties, or even just deciding how to split chores with roommates.
You're spot on. Cooperative game theory provides a framework for understanding how coalitions form, how the benefits of cooperation are distributed,
Okay.
and how to ensure that everyone involved feels like they're getting a fair deal.
That sounds incredibly valuable, especially in situations where trust and fairness are paramount. So how does cooperative game theory actually work? What are the key concepts?
One of the fundamental concepts is the characteristic function. It essentially measures the power of each possible coalition. It tells us how much value each group can achieve by working together.
So it's like a scorecard for each possible team, showing their potential to create value.
That's a great way to put it. By understanding the characteristic function, we can start to analyze how the benefits of cooperation should be divided among the participants.
So it's not just about forming coalitions, but also about making sure the rewards are distributed fairly.
Absolutely. Fairness is crucial in cooperative game theory. And there are different ways to define and measure fairness.
I imagine that can get pretty complex, especially when you have multiple players with different interests and contributions.
It certainly can. One important concept for measuring fairness is the core. Think of it as the set of all possible solutions, where no coalition has an incentive to break away and form a new group.
So it's like finding a stable arrangement where everyone is content with their share of the pie.
Precisely. But sometimes finding a solution that satisfies everyone can be challenging. In fact, the core might even be empty in some cases, meaning there's no solution that prevents some coalition from feeling like they'd be better off going their own way.
That sounds like a tricky situation. What do you do then?
Well, there are other concepts that can help us find fair solutions, even when the core is empty. One of the most well-known is the Shapley value.
The Shapley value, what's that all about?
It's a way of assigning a value to each player based on their individual contribution to the overall cooperation. It essentially measures how much each player brings to the table, taking into account all the possible coalitions they could be a part of.
So it's like quantifying each player's importance to the team effort.
Exactly. And the Shapley value provides a way to distribute the benefits of cooperation fairly based on those individual contributions.
This is all so fascinating. I'm starting to see how cooperative game theory can be used to analyze and solve complex problems involving collaboration, from negotiating business deals to fostering international cooperation on issues like climate change.
You're absolutely right. It's a powerful tool for understanding and navigating the dynamics of cooperation in a wide range of settings.
This entire deep dive into operations research has been incredibly eye-opening. We've gone from optimizing systems to strategizing in games to fostering cooperation. It's amazing to see how these tools can be applied to make better decisions in so many different aspects of life.
I'm glad you found it insightful. Operations research offers a diverse set of frameworks and techniques for tackling complex problems and making more informed choices, whether we're dealing with logistics strategy or human collaboration.
I have to say, I'm feeling a lot more equipped to approach those tricky decision-making moments now. It's like having a new set of lenses through which to view the world and its challenges.
That's the beauty of it. Operations research empowers us to move beyond gut feelings and embrace a more structured and analytical approach to problem solving. And as you continue to explore this fascinating field, you'll undoubtedly discover even more ways to apply these powerful tools in your own life.
I can't wait. Thanks for joining us on this incredible deep dive into the world of operations research. It's been a truly enlightening experience.
It's been my pleasure. Until next time, keep those analytical minds buzzing.